this video, we're going to look at solving a system of equations by graphing. And here's what we mean. There's going to be something like, which we'll do this example in a second, y equals negative 5 over 3x minus 6. But then there will be another equation that says y equals 1 over 6x plus 5. And our job is to find the x and y that actually solves both of these. So the solution is an ordered pair, and the ordered pair will satisfy both of these equations. Okay, so that's what we're doing in short, but we're going to do it by graphing first. So what we're going to look at is first 3 different variations that you could see. So let's just talk about that for a second. So let's go down for a minute. Let's actually get this graph where we can see it. All right, so now if I have this x and y coordinate, or x and y plane, actually, let me shrink this just a little bit. There we go. All right, so if I have this coordinate plane and I want to graph, hang on just a second. All right, so I could have 3 different variations. Now, let's say I graph a line. Let's say I graph 2 lines and this happens. Let's say this is one line and then here's another line. Okay? The good thing about that is wherever these 2 lines intersect, that's the solution. So this is the answer. So that's one variation you could see. You're going to graph the 2 lines, and wherever they cross, that's the answer. So that's, I mean, if you can graph a line, you're pretty much good to go on this. Okay, the other solution that could happen, let's say I have a line that looks like this, but then I also have another line that looks the exact same, except they're just parallel. If there are lines that are parallel, which means they have the same slope, so if 2 lines have the same slope and they're not the exact same line, that means there's no solution. Okay? Now, let's say if 2 lines do have the same slope, but then I basically graph the same line. So let's say I have this purple line, but then I have the same exact line right over it, which my graphing or my drawing skills are bad, but you can tell those lines are right on top of each other. If that happens, then your answer is infinite solutions. All right, so those are the 3 variations you could see. Now let's actually look at a problem. So once again, you may, well, as long as you can graph, you can pretty much handle these with ease. I would recommend using a ruler to make your line straight. All right, so use a ruler to make your line straight or a straight edge, but you'll see I'm going to have a little bit of trouble because I just struggle to draw straight lines. But let's go back to this example. Y equals negative 5 over 3x minus 6. And then my other equation is y equals 1 over 6 plus 5. Now, my job is to graph both of these. So once again, your first step is to just graph each. So graph each of these. All right, so let's start with the first line. We're going to say that m equals negative 5 over 3, and that my b is negative 6. So my first point is going to be at negative 6 on the y-axis. So 1, 2, 3, 4, 5, 6. So right down here. Now, I'm supposed to go down 5, and to the right 3. But if you notice, I'm going to run out of room down here. So once again, I've covered this in a previous video. You can take negative 5 over 3 and just do the opposite. So instead of going down 5, we can go up 5. And instead of going right 3, we can go left 3. So let's do all that. Let me get rid of this first. All right, so we're going to go up 5, 1, 2, 3, 4, 5, and to the left, 1, 2, 3. And then let's just make another point to be exact. Up 1, 2, 3, 4, 5. To the left, 1, 2, 3. All right, so there are all my points. Now I'm going to draw a line through each of those. So here's my first line. Let me actually make this as straight as I can. That looks pretty straight. All right, so there's my first graph. Now, let's do the second line. My slope is 1 over 6. My b is 5. So I'm going to start at positive 5. 1, 2, 3, 4, 5. And then I'm going to go down 1. So 1 over 6 means down 1. I mean up 1. What am I talking about? Up 1 and then right 6. All right, so I'm going to go up 1 over 1, 2, 3, 4, 5, 6. But now, once again, if you notice, if I tried to make another point, I'm going to go to the right and I would fall off the graph. So once again, what we can do is change this and go down 1, but then I can go to the left 6. So now down 1, to the left 1, 2, 3, 4, 5, 6. And if you notice, I ended up crossing this line. I actually had 2 points that were in the same exact spot. That automatically tells you the answer, but let's just graph this one just to show it. That looks about right. All right, so now the good thing for us is wherever these two lines intersect, that ordered pair is the answer. So that ordered pair would be at, let's see, negative 1, 2, 3, 4, 5, 6. So negative 6 is my x, and then my y is 1, 2, 3, 4. So negative 6, positive 4. That is the x and the y value that makes this these system of equations. It actually solves these two. Let's look at another one. I need to get rid of all this mess for a second. So now, once again, if you can graph a line, well, graph two lines, you're pretty much good to go on this. And I think most of us can graph lines. So the good thing about the graphing is, most of the time, it's pretty straightforward. All right, so let's say we have y equals 5, and then we have y equals 2x plus 7. All right, so now, y equals 5, that's a horizontal line. I put up some videos about, well, one video about this if you want to go back and check that out. But we're going to go to 5 on the y-axis, 1, 2, 3, 4, 5. And then we just need a horizontal line that cuts through the y-axis at 5. So there is our graph. Boom and boom. All right, so now the only other thing we need to do is graph this line. So my b is 7, my slope is 2, which is also 2 over 1. So I'm going to go to 7, 1, 2, 3, 4, 5, 6, 7. And I'm going to go up 2. But if you notice, I run off the graph. So once again, 2 over 1 just means up 2. I can change that to give me more points. I can just reverse it and go down 2. And then I'll go left 1. All right. So now I'll go down 1, 2, and then to the left 1. Now, if you notice, we've already hit our second line or our first line, so we can actually just stop here. We don't need to make a ton of other points. It would just be a little bit overdoing it. All right, so now wherever these two lines intersect, that's the answer. So the answer is, let's see, that would be at negative 1. Should be negative 1, 5, unless I'm crazy. But I think it would be. All right, so let me show you just one more. That way you can see an example of no solution, and then maybe I'll show you a quick infinite solution. All right, so now let's get rid of all this. Let's say I have 3x plus 6, y equals negative 12, and then my other line is y equals negative 1/2 x minus 5. Now, with this equation, if you notice, it's not in slope-intercept form, so I need to put it in slope-intercept form. And I've uploaded a video where I go through that process. But we would subtract 3x, and then we would divide 6, so we would end up with negative 1/2 x minus 2, I believe. Now, if you notice, the slopes of these lines look the exact same, well, they are the exact same. So this is either going to be a parallel line or it could be the same line. Now, if you notice, it doesn't look like the start points are the same, so it's probably not the same line, but let's just look at it anyway. But if it is parallel, that means our answer is going to be no solution. So let's see if that happens. Let's just graph both of these real quick. Let's just see if that happens. So the first line, we're going to say, we're going to start at -2, which would be here. And we're going to go down 1, 2, actually, we're just going to go down 1 and over 2. And then let's do another one, down 1 over 2. We'll do a couple more just so I can draw it straight. You probably don't need that many, but I want to have that many because I am a sloppy grapher. All right, that looks pretty nice. So there's our first line. Let's do our second line. Now, as long as these two aren't the same exact lines, then that just means the answer is no solution. And watch what happens when I graph this second line. You'll notice that now I'm starting at -5, and if I start at -5, there's no way these two lines are going to be the same exact line, so we actually just have parallel lines. Because once again, the slopes are the same, and the lines are not the exact same line, therefore these two lines have to be only parallel, so the answer is no solution. So if you have two parallel lines and they're not the same line, then the answer is no solution. All right, let's look at one more. Let me show you an example of when two lines are the same. All right, so once again, if lines are parallel, it could be no solution or it could be infinite solutions because they could be the same line. And you'll see on this example, the two lines that I have are actually going to be the same line. So let's do, so we have -y equals -x minus 6. And then my second line is 3x plus 18 equals 3y. So now on both of these lines, they're not in slope-intercept form, but watch what happens when I put them in slope-intercept form. So I'm going to divide -1, divide -1, y equals x plus 6. On this line, I actually just need to divide 3. And then I can move this around to be y equals, it'd be x plus 6. Now, if you notice, these two lines are the exact same. And when I graph this, if I'm graphing the same line, that means they're going to be at the exact same spot. So 1, 2, 3, 4, 5, 6. I would go up 1 over 1, up 1 over 1. I could also make a few extra points here. But no matter what I do, this line, or these two lines, are going to be the exact same. And if the lines are the exact same, that means your answer is infinite solutions. So infinite solutions. So there's a good example of all three variations. But once again, if you can graph a line, then you can do this. Just remember that when we're solving a system of equations, if the graphs intersect, then wherever those graphs intersect, that's the actual answer. If two lines are the same, like this example, then the answer is infinite solutions. If you have two parallel lines that don't intersect and aren't the same line, then you say no solution.